Imagine a celestial snowball hurtling through the vast expanse of space, its tail shimmering with a ghostly glow. This is the comet, a cosmic enigma that has fascinated humanity for millennia. These celestial travelers with their icy hearts and fiery trails have been the stuff of legends and lore, often viewed with awe and trepidation. In ancient times, they were seen as harbingers of doom or omens of divine intervention, their sudden appearances and departures stirring the imagination and fear of the unknown. But today, we see comets not as omens, but as opportunities. Opportunities to peer into the past, to understand our solar system's infancy, to uncover secrets about our planet's history. Comets are like cosmic archaeologists, carrying with them the primordial stuff of the universe, frozen in time. As we delve into their mysteries, we draw back the veil on our own origins. In this journey, we will unveil the top 10 discoveries made from the study of these celestial travelers. At number 10, we have the discovery that comets are primordial, formed from the original material of our solar system. This is no small revelation. It's as if comets are celestial time capsules, preserving the raw ingredients that gave birth to our solar system around 4.5 billion years ago. What's the evidence, you may ask? Well, comets are icy bodies, and much of that ice is water ice, but not just any water ice. The water found in comets has a unique isotopic signature, one that closely matches the water found here on Earth. This suggests that comets could have potentially delivered a significant portion of our planet's water. But it's not just water that comets carry. They are also rich in organic compounds, the building blocks of life. These compounds include things like methane, ammonia, and even formaldehyde. When these compounds interact with water and sunlight, they can form amino acids, the building blocks of proteins, and life as we know it. The implications of these discoveries are profound. They suggest that comets played a crucial role in the early solar system, perhaps even contributing to the emergence of life on Earth. And they tell us that the materials necessary for life are not unique to our planet, but are scattered throughout the cosmos. This discovery opened a window into the ancient past of our solar system. The 9th spot is held by the discovery of the nature of Comet Tails. As a comet journeys closer to the sun, it begins to heat up and its icy nucleus starts to vaporize, releasing gas and dust into space. This creates the comet's glowing coma and forms the 2 types of comet tails, dust and ion. The dust tail, made up of tiny particles, reflects sunlight and often appears yellowish-white to the naked eye. It generally trails the comet along its orbital path. On the other hand, the ion tail consists of charged particles pushed directly away from the sun by the solar wind, regardless of the comet's direction. This tail tends to glow with a bluish hue. Understanding the composition and behavior of these tails has been pivotal in comprehending how solar wind interacts with cometary material. This interaction is a small but significant piece of the cosmic puzzle, contributing to our broader knowledge of the solar system's dynamics. The comet's tail, a spectacle to the eye, is a phenomenon that has much to tell. 8th on our list is the discovery of the nature of a comet's nucleus. The nucleus, essentially the core of a comet, is a fascinating cosmic entity. It's a chunk of rock and ice, often irregularly shaped, and can boast a variety of intriguing surface features, from craters and cliffs to fissures and vents. These features are more than just aesthetically captivating. They're cosmic clues, telling us tales of a comet's history and formation. The composition of cometary nuclei is equally riveting. They are not just chunks of ice and rock. They are a cocktail of water ice, dry ice, ammonia, methane, and a host of other volatile substances. And let's not forget the dust. Lots of cosmic dust. When the comet nears the sun, these ices sublimate, creating a cloud of gas and dust around the nucleus known as the coma. The irregular shapes of these nuclei, ranging from elongated to bilobed, are the result of low-gravity environments and a history of collisions and amalgamations. Each shape, each contour, each scar on a comet's nucleus has a story to tell. Stories of the early solar system, of primordial cosmic events, and of the building blocks of life as we know it. In essence, the nucleus, the heart of the comet, is a trove of cosmic secrets. Its study brings us one step closer to understanding our place in the cosmos. the origins of water, and perhaps even the emergence of life on Earth. Coming in at number 7 is the discovery of the potential link between comets and Earth's water. This theory, known as the comet water hypothesis, has gained traction over the decades as more evidence comes to light. You see, comets are ancient relics of the early solar system, composed largely of ices such as water, carbon dioxide, and ammonia. When these celestial objects venture close to the sun, their icy cores heat up, spewing out gas and dust to form a glowing coma and a tail. Now let's pause for a moment and think about Earth, our blue planet. It's covered in vast oceans of water, but where did all this water come from? One compelling idea is that it was delivered by comets. These icy wanderers, after all, are rich in water, and in the early days of our solar system, the Earth was likely bombarded by a large number of them. Recent studies of the water in comets have found that it often contains a similar ratio of hydrogen to deuterium, a heavier form of hydrogen, as the water on Earth. This is significant because it suggests a common origin for the water in comets and our oceans. So, the next time you take a sip of water, consider this. The water you're drinking might have traveled billions of miles across space, carried by comets, to reach your glass. Could our oceans owe their existence to these icy wanderers? The answer may lie in the stars. At number 6, we have the discovery of organic compounds on comets. These icy wanderers of the cosmos are not only fascinating for their majestic tails and ancient origins, but also for what they carry within their frosty cores. Among the most intriguing components found on comets are organic compounds. These are molecules containing carbon, the element that is the basis of life as we know it. One such compound that has been detected on comets is formaldehyde, a simple organic molecule that can contribute to the formation of amino acids, the building blocks of proteins. Other organic compounds found on comets include methanol, ethanol, and even complex sugars, all of which are essential ingredients in the cosmic recipe for life. These discoveries are not merely interesting, they hold profound implications for our understanding of life's origins. The presence of these organic compounds on comets suggests the tantalizing possibility that the building blocks of life could have been delivered to Earth from space, sparking the process that led to the evolution of life as we know it. In the realm of astrobiology, the study of life in the universe, these findings are monumental. They suggest that the ingredients for life may be widespread throughout the cosmos, perhaps even common on other planets and moons. This discovery brings us one step closer to understanding the cosmic recipe for life. It's a tantalizing thought, isn't it? The seeds of life, scattered across the universe, just waiting for the right conditions to bloom. Halfway through our list at number 5 is the controversial theory linking comets to mass extinctions on Earth. Yes, you heard it right. The very celestial bodies that we've been discussing as life-bringers might have also been life-takers. This theory is based on the catastrophic events that occurred millions of years ago when a massive comet or asteroid hit our planet, causing a global climate shift. The most famous of these events is the extinction of the dinosaurs, which is widely believed to have been caused by such an impact. Evidence supporting this theory includes the presence of iridium, a rare element on Earth but common in space, found in the geological layer marking the time of the extinction. In addition, shocked quartz and tektites, indicative of a high-energy impact, have been discovered at various extinction-level event sites. But are comets really to blame, or are they merely cosmic scapegoats, comets, bringers of life or harbingers of doom? The jury is still out. Fourth on our list is the groundbreaking Rosetta mission and its study of Comet 67P. Launched by the European Space Agency, Rosetta traveled for over a decade through the cosmos before rendezvousing with Comet 67P, a hunk of rock and ice hurtling through space at unimaginable speeds. But why all this fuss over a comet? Well, the answer lies in what Rosetta discovered. The first shocker was the landscape of the comet. Far from being a simple, inert body, Comet 67P turned out to have a remarkably diverse and complex landscape. It was a world unto itself, with towering cliffs, deep crevices, and vast plains. This challenged our previous notions of comets as mere dirty snowballs. The second groundbreaking discovery was the detection of molecular oxygen in the comet's coma, the cloud of gas that a comet releases as it nears the sun. This was a surprise because molecular oxygen is highly reactive. It tends to bind with other elements and compounds. Finding it in such abundance suggested that it was likely frozen into the comet's nucleus when the solar system was still young, providing valuable clues about the conditions present during the formation of the solar system. These discoveries, among others, have helped scientists paint a more nuanced picture of comets and their role in the cosmic ballet. The Rosetta mission has rewritten the book on comets. So the next time you wish upon a shooting star, remember that it's not just a spark in the night, but a window into our cosmic past. At number 3, we have the discovery of Oumuamua, our first known interstellar visitor. This celestial wanderer was first spotted in October of 2017, casually passing through our solar system. Unlike the comets we're accustomed to, Oumuamua didn't come from our own cosmic backyard. It was a visitor from the deep, dark expanses of interstellar space. What makes Oumuamua so special, apart from its extraterrestrial origin, is its peculiar shape. Imagine a chunk of rock, half a mile long but only 80 yards wide, shaped rather like a cosmic cigar. This elongated form is unlike anything we've seen in our solar system, making Oumuamua a unique puzzle for astronomers to solve. But the intrigue doesn't end with its shape. Oumuamua displayed non-gravitational acceleration as it left our solar system, hinting at the possibility that it might not be a comet or an asteroid, but something entirely new. Some even dared to speculate it could be an alien artifact. Oumuamua's discovery has opened up a whole new frontier in the study of comets and the universe at large. It has shown us that our solar system isn't isolated. We're part of a much bigger cosmic neighborhood, with celestial bodies traveling between stars, just like Oumuamua. Oumuamua, a cosmic drifter from the vast expanse, has broadened our cosmic perspective. Our runner-up is the realization that comets serve as cosmic time capsules. Just as a time capsule buried in the ground can provide insights into the past, comets, frozen relics from the dawn of our solar system, offer us invaluable clues about our cosmic infancy. Comets are remnants of the early solar system, composed of ice, dust, and rock, preserved in the cold reaches of space. They're like fossils, providing a snapshot of the conditions present during the formation of our planetary system. By studying comets, we can glean information about the materials and processes that were instrumental in the creation of the planets, including Earth. These icy voyages carry within them the original materials from the solar nebula from which our sun and planets formed, over 4.5 billion years ago. Their preserved composition allows us to peer back in time, to an era before the planets even existed. Comets, frozen in time, hold the secrets of our cosmic beginnings. And finally, at number 1, is the monumental discovery of life's building blocks on comets. Imagine a world where life as we know it didn't originate from the primordial soup of our own planet, but was instead delivered from the icy reaches of space. This isn't the plot of a science fiction novel, but a real hypothesis scientists are exploring. Comets, these icy celestial bodies that have been journeying through the solar system for billions of years, are more than just beautiful spectacles in our night sky. They are carriers of ancient secrets frozen in time, waiting to be unlocked. And one of these secrets is the discovery of amino acids on comets. Amino acids are the fundamental building blocks of proteins, the workhorses of all living cells. They play a crucial role in virtually all biological processes in life as we know it. To find these complex molecules on comets is truly a monumental discovery. It suggests the intriguing possibility that the seeds of life might have been sown not only on Earth, but perhaps throughout the cosmos. This discovery lends credibility to the panspermia hypothesis, the idea that life, or the building blocks of life, could have been transported to Earth aboard comets or meteorites. It's a radical concept that challenges our traditional understanding of the origins of life. But consider this. Our planet, in its early stages, was a hot, violent place, not exactly hospitable to the formation of delicate organic molecules. In contrast, the cold, stable environment of a comet could provide the perfect conditions for these building blocks of life to form. So could it be possible that life on Earth was kick-started by the delivery of these crucial ingredients from a comet impact? The answer is still up in the air, but the discovery of amino acids on comets certainly adds a thrilling twist to the story of our cosmic origins. Comets, it seems, are not just icy wanderers, but cradles of life's beginnings. And now, we turn the telescope back at you, our curious and passionate viewers. You've journeyed with us through the mysteries of comets, from their primordial origins to their potential role in the birth of life itself. We've traversed the cosmos together, and we hope you've discovered something new and fascinating in this journey. Did you know that comets could be the cosmic mailmen of life's building blocks? Or that these icy wanderers could hold the key to the origins of life itself? If you've learned something new today, please give this video a thumbs up. It helps us a lot. And what do you think about the panspermia hypothesis? Do you believe that life on Earth could have been kick-started by a comet's icy delivery? Share your thoughts, ideas, and questions in the comments below. We love hearing from you and engaging in these cosmic conversations. We're all explorers in this vast universe, and each new discovery brings us closer to understanding our place in it. So don't miss out on the next cosmic journey. Subscribe to our channel and hit the bell icon to ensure you're notified every time we embark on a new adventure. And finally, if you've enjoyed this journey, share it with your friends and family. Let them join us in exploring the mysteries of our universe. After all, the cosmos is a lot more fun when we explore it together. Remember, every star in the night sky could be a sun to someone else. Keep looking up, keep asking questions, and keep exploring. Until next time, this is your cosmic companion signing off.